So likely the most important specification when it comes to windows is U value. So U value is the opposite of R value. So R value measures the resistance of the flow of heat. U value measures how well something transmits or conducts heat. So the technical definition is that a U value measures how thermally conductive a material is, meaning how well a material transfers heat. So we want the U value when it comes to windows to be low because we don't want it to transfer heat. We want it to protect the home from the outside elements, keep the heat in. We want it to slow the loss of heat from the home in the wintertime and slow the gain of heat in the summertime. So the lower the U value, the better, meaning the more resistant the material is to conductive heat flow. So to look at the math for a second, 1 over the U value of something equals R value. All right, so they're the inverse. 1 over the R value equals the U value. So an example of this would be a window that would have a U value of 0.25. So 1 over 0.25 equals 4. That window would have an effective R value of R4. Now, if you had a window that had an R value of R10, which is a very, very high R value when it comes to windows, that would be a 0.1 U value, right? So that just gives you kind of a general sense of U value. If you love nerding out on solar technology and home energy stuff, feel free to click the subscribe button below so you'll get access to the upcoming free videos I'll be posting. Now let's talk about conductive heat transfer. So if U value slows conductive heat transfer, remember conductive heat transfer is when molecules are in direct contact. So the number of panes of glass are going to have the biggest impact on conductivity or increase in R value, reduction in U value, which is what we want, right? So if you have 2 layers of glass, you're going to have a space between them. They're going to slow down that transfer of heat. The molecules are going to start to kind of warm up that external pane of glass if it's the summertime. And then inside that pane of glass, you usually have a vacuum or as close to a vacuum as you can get. And it takes a longer time for those molecules to kind of move and heat up the interior pane of glass and ultimately transfer that heat to the molecules inside of the window. If you imagine 1 layer of glass, you would have a very high U value, a very low R value. You'd have a very, very simple way for heat to transfer, right? Those molecules would heat up that single pane of glass, which would in turn heat up the molecules inside of the house or outside of the house. Some windows even have 3 or 4 panes of glass. You can imagine in this scenario, you just have a lot of space that is kind of used to slow down conductive heat transfer, right? You have that first pane, you have these molecules that are not moving around too much inside of that vacuum. Then you have another pane, then you have more molecules. They're really separated very well from conductive heat transfer, right? So 3 layers of glass is going to be one of the most effective means to slow down conductive heat transfer. One way you can enhance that increase in R value, reduction in U value is to put a special gas or material in the form of a gas in between those panes. So air is obviously most common, and then you can add things like argon or krypton or a mix of these different gases to create a more resistant surface to heat flow. So air is going to be okay, argon is going to be better, krypton is going to be the best. So if you imagine there's other parts to the window than just the glass itself, and the frame actually has a big impact on conductivity, right? That's a material in itself. So if you think about the molecules not just hitting the glass, they're also in contact with the frame around the glass, and that frame is going to transfer heat across it to the inside in the summertime or to the outside in the wintertime, heating up the other components of the window, ultimately, which transfers that heat to the inside or outside of your window. So different materials obviously transfer heat better or worse. Metal is a very, very good conductor of heat flow, meaning it's bad for insulation. So when you have a metal or aluminum window, the U value is 1, which is pretty high for a U value. The R value is 1, which is pretty low for the R value. Remember, high U value equals low R value, and vice versa. You get into a more effective window, it might be, in terms of a frame, it might be wood, which has a U value of 0.4 and an R value of 2.5. Vinyl is a worse conductor, meaning it's a better insulator. It's got a lower U value and a higher R value of R3. Fiberglass will typically have an R value of R4 in a window frame, and the U value will be 0.25, typically around there with a dual pane fiberglass window. So let's see how these all kind of play out together. You're going to see the lowest performance typically with a metal frame. Wood and vinyl are very, very good, and fiberglass frames are great. The other factor that actually does make a difference is the filling that goes inside of the frame. So if you imagine that frame itself has these gaps inside of them, these holes, these areas where typically it could be an open space, you can actually fill those gaps with foam, with expanding foam, and those foam materials will slow the transfer heat even more. The quality of the installation also makes a huge difference. So most windows are retrofit, meaning there's an existing frame that stays in place when the new windows are installed, and then there's little kind of vinyl or trim materials that are put around these openings to create the kind of finished aesthetic. Because that existing frame is typically left in place, mostly because it's very, very expensive to kind of rip out the existing drywall and stucco around these frames, you're going to want to make sure that when somebody goes ahead and foams those frames, they do a complete job. There are no gaps, there are no cracks. The more thorough the work is done to foam that window, the less gaps you're going to have. So in this case, it looks like, oh, he's doing great, he's foaming the window. But if this foam doesn't expand all the way to the top, that's an opportunity for conductive heat transfer. And so you want to make sure there's a thorough job done with foaming around existing or retrofit window frames. So if you look at this all together, what you're going to find is that when you have a single pane window, the frame is not going to make such a big difference because you have such significant losses from that single pane. You're going to have U values as high as 1 with R values as low as 1, right? And it's going to be pretty consistent even with wood, fiberglass, or vinyl. When you get into the double pane windows, that's where the frame is going to make a bigger difference. You'll see, your R values on double pane metal are typically only up about R2, while wood, fiberglass, and vinyl with double pane windows can get up to about R3, 3.5, in some cases even R4, depending on the gas that they have inside of it. And then you can even go to triple pane windows, not as common and not recommended if you have a low R value on your wall assembly because of the weighted R value theory that we talked about in R value, the analysis section there. But what you're going to find is that when you get into those triple pane windows, even the metal frames have a high performance because they're going to break that metal with plastic between it. So they're not going to have a continuous piece of metal from the outside to the inside. They're going to have pieces of plastic or vinyl separating the exterior metal and the internal metal. And then you can get really high performance windows up to R8 in triple pane windows. And then if you're going super, super high performance, maybe you're up in Alaska, you can add up to a 4th pane of glass and get R values up to R12, which is amazing for a window assembly. So that's the summary when it comes to U values as it relates to windows. Remember, it's the opposite of R value, so we want that U value really, really low, and that's going to have the biggest impact on the comfort of your window assemblies, which will lead to a comfortable and high performance home. If you totally love this home energy stuff, just click the subscribe button below so you'll continue to get more great free content.